Okay, so Fred opens a metal container. So it's an open metal container. It's one of the key things here. It's a cuboid. So the height is x, width x, and length y. The volume is 36. So given that they've given us this information that the volume, so then the volume of this cuboid, oh my gosh, where's these? So 36 would be equal to x multiplied by x multiplied by y. So 36 is x squared multiplied by y. We need to look at the surface area of the container. So the surface area of the container, so we've got this front side, which would be an x multiplied by y. We've got the back, which is the same as that. So that's, and then the bottom, which is another x multiplied by y. So we've got 3x multiplied by y. So the surface area. And then we've got these two side bits. So we've got plus 2x squared. Sorry, I should have confirmed. So this is x multiplied by x, so that's x squared. So 1, 2, 3, 4, 5 sides. We don't count the top because it's an open container. So surface area would be this. Now, this has got y's in it, but this doesn't. So this is where this information here comes in useful, because we can rearrange this formula to give us y equals 36 over x squared, and then we can replace this for this y here. So we've got 3x multiplied by 36 over x squared plus 2x squared. This is over 1. So we've got x on the top and x squared on the bottom, so that cancels. 3 multiplied by 36. Even if you weren't sure, you could have a look at this to see if it can help you. So that's 108 over x plus 2x squared. So there we go, we've shown that that's an expression for the surface area. Now the reason that they do show that, so as I've said before, is because if you didn't get this, then you'd be cut off from doing the rest of the question. But because it's a show that question, we can carry on even if you didn't get these 4 marks. So they've now asked us to find a dash x, so we know that means finding the derivative. When we differentiate expressions, if there's x's on the bottom, remember the first thing we should do is rewrite it. So x is 108 x to the negative 1, because there's a secret power of 1 on the bottom, plus 2x squared. So I haven't differentiated yet, I've just rewritten it. Now I can differentiate. So it's negative 108 x to the negative 2 plus 4x. So I've differentiated it. It's the non-calc paper, so I would suggest probably at some point the fact that we've got this negative 2, x to the negative 2 isn't going to help us. So make sure that you're comfortable with going back to fraction format. So this is negative 108 over x squared plus 4x. Now it says, given that the outside area, surface area is a minimum, find the height of the container. Well, when we see expressions like things being minimums or maximums, it tells us that the derivative, so when we see minimum or maximum, it tells us that the derivative is equal to 0. Seeing as they've just asked us to find the derivative, that's why that's helpful. So we know that 0 is equal to negative 108 over x squared plus 4x. This is negative, so we don't like that. We're going to add that to both sides. So we get 108 over x squared equals 4x. X is on the bottom, which isn't useful, so we multiply both sides by x squared. So we get 108 equals 4x cubed. Deal with this 4. So it's 108 over 4 equals x cubed. Now if you're not very good at dividing, just literally go back to basics. So 4's into 1 doesn't go. 4's into 10 goes twice, remainder 2. Oops. 4's into 28. Oh, God. Oh. 4's into 28 goes 6. Oh my gosh, what am I saying? 4's into 28 goes 7. It's really awkward, isn't it? So, x cubed is 27. Now we need to take the cube root of that. So we need to know what number multiplied by itself gives 27. Well, you know that 2 multiplied by itself gives you 8. So let's try 3. So 3 multiplied by 3 is 9. Multiplied by 3 is 27. So there we go, there's our answer. X is 3. Now, that's not our final answer though. It says find the height of the container. Let's just double check. So the height of the container is given by the value of x. So we're good to go. That is the answer. So the height is 3 meters. Is it meters? Sure, meters. Alright, so next, final part of the question. Fred paints the outside of the container. A tin of paint covers a surface area of 10 and costs $20. Find the total cost needed. Alright, so if we need to know how much paint we're going to need, we need to know our surface area. So we're going to use our surface area formula here with our value of 3 that we just found. Sorry, focus. Sorry. So 108. Oops, 108 over 3 plus 2 lots of 3 squared. So 3's into 108. 3's into 10 goes 3 times, remainder 1. 3's into 18 goes 6. 36 plus 2 lots of 9. 36 plus 18 is 54 meters squared. It's an area, so it's squared. Right, so if a tin of paint covers 10 meters squared, then that's going to be 5.4 tins. Can you buy 0.4 tins? No, so you need to buy 6 tins. And if each of them costs $20, it's going to be 6 multiplied by 20, which is $120. Alright, final question. Here's a quadratic function. The vertex is here. It can be written in this form. So they've given us the vertex already, and so if it can be written in this form, I know that it would be x minus 1 squared minus 9. We can see that it's over here on the right hand side, so that's why we would write minus 1 here. Right, so having established that's the equation, let's now compare it to this, because this is where lots of people make mistakes. So it's x minus h. We've got a minus here already, which means that this value here is the value of h. So h is 1. H is not negative 1. Okay? And then k is this value here. Well, this is negative 9. That was plus k. So then k is negative 9. Find the value of c. That's where it crosses the y-axis. Well, it's going to cross the y-axis when the value of x is 0. So, let's see if I can squidge it in. So, it crosses when x is 0. So, that's 0 minus 1 squared minus 9. So, all I'm doing is substituting it into my equation here. So, negative 1 squared is 1. Take away 9 is negative 8. So, that's the value of c. Gx is blah blah. The graph of G is obtained by a reflection of the graph of F followed by a translation. So they've said it's reflected. So let's now imagine that. So this is now the coordinate 1, 9. Okay, so this is now 1, positive 9, having been reflected, and the reflection is shown by this here. It now needs to follow a translation of PQ. So we're going to end up with our vertex at the value 3, positive 1. So let's find that coordinate. So that would be 3, positive 1. 3, 1. So how have we gone from being up here to down here? Well, we've gone to the right 2 and down 8. So we've gone a translation of 2, negative 8. So P is 2 and Q is negative 8. Find the x coordinates of the points of intersections of the graph, or points of intersection of which graphs? Of f and g. So that means that we're going to be equating our two functions. Let's erase this so I can see what I'm doing. So negative x minus 3 squared plus 1 is going to meet x minus 1 squared minus 9. Okay, that's what points of intersection are all about. It's where graphs meet. So we need to do some FOIL. So our negative I'm going to leave for now. So we've got negative. So x squared minus 3x minus 3x plus 9. X squared minus x plus 1. So now this negative affects everything in here. So it's negative x squared plus 3x minus 9 plus 1. You can enjoy my lifetimes together there. So we've got negative x squared plus 6x. Negative 9 plus 1 is negative 8. Equals x squared minus 2x, and then 1 take away 9 is negative 8. Right, so now I need to join everything to the same side. So I'm going to add the x squared to both sides. So I've got 2x squared. I'm going to take away 6x from both sides. So that's negative 8x. And I can see that they're common, so they just cancel out. So I'm going to factorize it. So I can see that 2x is common. Solving this, if it's equal to 0, then either this is equal to 0, which means that x is 0, or this is equal to 0, which means that x would be 4. And they only want to do the x coordinates, so they are the answers. And we're done.